Okay, let's look at what these looks like when you did them. First, y equals 2 over x. Well, this is already in y equals form, and you can see right away it's in y equals a divided by x form, so this is clearly an inverse variation. For y equals 3x, you divide both sides by 4 to get it in y equals form, and you get y equals 3x over 4, or 3/4 x. That is a direct variation equation, right? You can see with a slope of 3/4, so that's direct. Then we have 5x minus y equals 3. Put it in y equals form. I'm going to bring the y over here to make it positive, and the 3 over here and make it negative. So I'm going to get y equals 5x minus 3. I can see right away that this cannot possibly be direct variation or inverse variation. Ooh, I should have capitalized that. This is neither, because it has a y-intercept of -3 instead of 0. It's not in the simple y equals ax form. Last, we're going to look at this, and to put that in y equals form, we're going to have to divide by x to get rid of it, right? The opposite operation, if it's multiplied by x, we have to divide both sides by x. And when I do that, I end up with y equals 1 over 2x. And you can see that that is going to be an inverse variation. Inverse, it does not matter if there's a number on the top or the bottom. What makes it an inverse or a direct variation is if the x is on the bottom, it's inverse if the x is on in the bottom or the denominator. If the x is on the top or the numerator, it is direct variation. Okay, having done that, we're going to go on to do some graphing. And the first graph we're going to do is we're graphing inverse variation particularly because we know the direct variation is just simply a line. So we're going to graph y equals 4 divided by x. Okay. And what we're going to do is just do what we've always done with graphs, and we're going to choose numbers and just see what happens. So I'm going to draw my coordinate system. Actually, let me draw it in black. I have a little bit more contrast if I can find black. There we go. Okay, and I'm going to start drawing a table over here. X, Y, and you're going to see why I'm going to do a second table, but let me just at least start with the first. Okay. So what do we usually do when we do these? We usually start with x equals 0. You cannot divide by 0, so very clearly that has to be undefined. And that's the first thing I put in. Actually, let me start. I just forgot to draw my 1, 2, 3, 4, my full coordinate systems with the numbers. Okay, so now that I go to x is 1, well, if x is 1, 4 divided by 1 is 1, so x is 1. That means y is going to be 4. If x is 2, I get 4 divided by 2, I get 2. If x is 3, I get 4/3, so 1 1/3. And if x is 4, I get 1. So it's sort of a bizarre thing. It looks like it almost becomes exponential at either end while it goes to very large x values and very large y values. It looks like it is exponential in both directions. But the thing with a hyperbola, which is what we're drawing right now, is there's another branch, and that's what they're called. They're called branches on the opposite side, because we have not yet done our negative x values. Okay, we've already gone through 0, and we know that we can't use that, so we're going to do -1. And -1 is going to give me -4. And -2 is going to give me -2. -3 is going to give me -4/3. If you're hearing a strange noise, it's my washer making funny noises. And -4 is going to give me -1. And I've got the other branch of my hyperbola, and I should really be going that way, down here. Okay, so very quickly, that is the hyperbola, or the inverse variation, or also called the rational function, and this is a hyperbola. And the hyperbola has a branch. This is a branch of the hyperbola, and this is the second branch of the hyperbola. And the other portion that I will define, I'm going to put that in red, is, can you see that the branches approach x equals 0 and y equals 0? You can see that they're going to approach this y-axis, right, which really is x equals 0, y equals 0, and this x-axis, but they're never ever going to hit the axes. And so these two, and I'm just going to do what these are over here, okay? I'm just going to draw in the corner. You've got your little branch here and your branch down there, and these lines that they come close to but never hit are called asymptotes. It's a kind of a long, complicated word, and that is what those are in red. Those are the lines that they come close to but never ever touch. Okay, so this is a hyperbola, and I should just define it down here. I've defined it before. And where a is 4, okay? You can see that this is the a value of this hyperbola. All right, the example that I just did is example 2. I'm just gonna write that up here in case you wanna compare it to what's in the book. And I'm gonna try to slip in example 3 because it's kind of nice to see them next to each other so you can compare them. If I do example 3, example 3 is going to give you something with an a value, which is negative, to see the difference. And so this one is going to be graph y equals -4 over x. Okay? And we're going to do that the same way. I'm going to draw my coordinate system. The only difference between these two is that one is positive and one is negative. Almost done. And because I'm rushing, it's not as pretty as the other one. Okay. So if I start doing my points, and I'm not going to do all of them because one, it's going to get really even messier than it already is, and two, it's not really necessary. I'm going to very quickly see a pattern. If x is 0, I'm still trying to divide by 0, so it's still undefined. If x is 1, I get -4. If x is 2, I get -2. X is 3, positive 3, I get -4/3. Sorry for the messiness there. Let me just put it in black, it might be clearer. And then if x is 4, I'm going to get -1. So what does that look like? 1, -4, sorry, 1, -4, I'm starting in the 4th quadrant, 2, -2, 3, -4/3, and 4, -1. And you're going to see that this is my first hyperbola branch for y equals -4 for x, and you're going to see the same thing over here, except in reverse. I'm going to do a -1, a -2, a -3, a -4, and when I do -1, I'm going to get a +4. When I go a -2, I'm going to get a +2, -3, -1 1/3, etc. And this is going to be my second. And you can see that essentially the negative is, just like it always is, a reflection. This hyperbola, it's as if this is reflected here and this is reflected here. So we've always said when A is negative, it's a reflection. And so this one is when A is less than 1, it is a reflection, right? And you can also see that it's a stretch, because if I had just 1 over x, it would be much, much closer, or -1 over x, much, much closer to the asymptotes, right? You remember the asymptotes is what the lines that they get close to but never ever touch. Okay, so that is the 2 graphs of the hyperbola, and I'm going to stop this video here, and I'm going to start the very beginnings of part 2 of this lesson, just because you may see a couple in your homework, and then I'll pick up the rest tomorrow.